In this video, we're going to look at configuring groups of data for querying using Kibana's index patterns. This video will teach us how to group similar data using index patterns. We'll look at time-based events as well as non-time-based events. We'll look at scripted fields and how we can get more data out of the data we have stored. And then I'll show you how the popularity and index fields work within the Discover tab. An index pattern in Kibana is where you need to start. When you think about an Elasticsearch cluster, we talked about the indexes that are created that hold the data for Elasticsearch to manage and to query and to store. Those indexes have names, and within Kibana, you need to tell it what indexes or by a pattern to search when you do your searches. So we need to set up this index pattern. We need to set a default index pattern. We need to pick which fields we're going to look at while we use Kibana. So I'll show you how we can do that. So when you first come to Kibana, it doesn't know what index pattern you want to use. So we'll look at this and we'll say, okay, I don't know what index pattern to use. So we need to create one. If we think about the example code we had in the last video, we had a cars for sale index. So here we can say, let's look at this cars for sale. Here, we can even put in a wildcard, cars F star. And we don't want to use a time filter for this example. I'll hit create. And so now that we've set up this quick index pattern, I'll go through this in a little more detail when we look at the time-based patterns. We know that Elasticsearch has at least one index that matches this wildcard. So cars F star. I know we have a cars for sale. So now that we've set up that index pattern, we can see it, and we can see here are the available fields within that index. So let's walk through a quick example besides that one index we had. It wasn't really a grouping of indexes, but using a wildcard, we can group indexes. So let's imagine we built an application that has a database backend and it has multiple groups. We're building a forum, and it's going to have multiple communities that people can join and chat and talk and all those kind of things that you do in a forum. Each of these forums will be related to our database that has a unique identifier for the forum or community. So we would create an index in Elasticsearch that would store all of our comments and whatnot. And we could name them something like community-1, community-2, community-3. Then we can use those individual indexes to store just the data for those communities. It's a great way to basically have a multi-tenant system within Elasticsearch. So when we look at Kibana, we would want to set up the index pattern using the wildcard, doing community-wildcard. Pretty straightforward. Then we can do searches and visualizations that are across all of those indexes that match the wildcard. So this would be great for an administration function. We can look for errors. We can look for trending terms across all of our forums for, advertising or anything we want to do there. Where this really gets good is when we start talking about time-based indexes. So imagine we have Apache logs. So the Apache logs are from a web server that you have running in your enterprise or in your open source tool that you host. We could have a daily index for those Apache logs. We could start with Apache logs -2017-01-01 to represent January 1st, Apache logs 2017-01-02, January 2nd, January 3rd, etc. So our index pattern would be Apache logs -star. And in this case, we're going to have time-based events because when you have a request to a web server, there's a time that it was initiated, a time it was completed, and a duration of how long it took. So let's look at our Kibana instance, and we'll set up a time-based index pattern for some data that I have running. So on this Elasticsearch cluster, I have metric beats running. The metric beat looks at CPU utilization, memory utilization, disk utilization, etc. And so what it does is creates a index per day of metrics. So now we'll go through this page slower. So when we first load Kibana, Kibana runs on port 5601 by default. And when we first go to Kibana, we'll see this page because no index pattern has been created. You'll see I deleted the one we had just created, so now I have none. If you get to Kibana and you look down the left side, you'll see this management page. That's where we are right now. So it's telling us we have no default index pattern, and so we need to create one. So one of the examples they have, or the default they have, is logstash-star. So logstash by default does the same patterns that I was just showing you. Now, interestingly, here we have a message that tells us it's unable to fetch the mapping. Do you have any indices matching the pattern? And in this case, we don't. But I know we have metric beats that are being created daily. So let's try that. We'll do a metric beat, I think it's 6.1.1-star. And so metric beat, when it creates the indices, it also creates it with its version name in it. It's all configurable. This is just default out the box. So here we've set up that index pattern by name, and since that error message went away, we know it matched something. Now we have a whole bunch of time fields. So there's things about Docker, Kubernetes, Postgres. Those are all applications that metric beat will monitor. I don't have them running, so none of those are going to have any data. But each record has a timestamp. So this timestamp is typically used as your default. So here we'll hit create for that index pattern. And now we can look at the fields that are used in those indices. So Aerospike, index ID, sources. Let's see, typically we want to find the things about system. Who knows how far back they're going to be. Here we go. So we found some system.socket, process, remote IP. We can also filter these fields if we want to. Let's find some disk. Here we go. Couchbase disk. There we system disk.io.time. So this is how we start finding the data within. All right. Now we've got to talk about scripted fields. So scripted fields are a field that we can display and we can chart on within Kibana, but they're not stored in the document within Elasticsearch. So we have a couple of choices here of using different scripting languages. One is the Lucene scripting languages. The other is Painless scripting. Painless is the easier one to use. So we'll show an example there. But these are calculated at the time of query. So after the query in Kibana. So here, we need to be careful. We can't mess these up. We can't do anything that will cause undue burden on the Kibana server. So I typically use these to add two fields together or do some simple math on them. The example I'm going to show, I'll do some concatenation of text just to show you what's going on. So here, let's find some data. So we'll look at this Discover tab, and getting rid of the message at the top, we can see in the last 15 minutes, we've got a whole bunch of records. Not too particular what those records are, but let's look at something. Let's find out what index they're coming from. So they're all coming from metric beat 6.1.1 2018-01-17. So today, in case you were curious, is 2018, January 17th. So those are good. Let's add beat.hostname so we can see this in our dashboard. And then what I want to do is figure out a way to create a scripted field to do something different to beat.hostname. So I know I'm going to mess with that. So let's go back to management. We'll do our index patterns. Click make sure metric beat is collected, and we'll do scripted field. So here we're going to add a scripted field. We'll call it beat hostname video. We'll do the painless language. We'll make a string. We'll format it as a string. Let's do some transforming for fun. So we'll make sure it's all lowercase. And so here, if we just keep scrolling down, I like popularity, so we'll move that up, and I'll show you why in a second. The example down here says, all right, we can set a doc. We can use a doc.someField value. So I know that beat.hostname is the field I want to do. So if we do doc, left bracket, single tick, field, right bracket, dot value. Let's see what happens if we try to add is a great server. All right, so that's our scripted field. So if we hit create, and there's a lot more information here about functions you can do on integers, on floats, on numbers, as well as strings and distance functions for geopoints, which we'll get into more. And now we can hit create. So we can see we created this field, beat hostname video. And the output we want to be the documents, beat hostname plus is a great server. So now if we go back to the Discover tab, we can see we have this beat hostname video field that's now added under the popular, see I told you I wanted to do that, and we'll get back to that in a second, the popular fields, and I can add it to my chart, and here we go. Elasticsearch 6 is a great server. So you'll see I hinted at the available fields, the selected fields, and those popular fields. So again, I'll remove this. I'll remove my beat hostname. And if we look at the popular section here, I increased the popularity of this beat hostname video field when I created it. So it's going to immediately show us popular. Over time, as you look at these different fields and you use them to query, use them to filter, you display them, Kibana will keep track of the fields in the indexes that you liked and that you regularly use, and you'll see them start popping up in this popular box. It's a quicker way for you to get access to them, to add them to your user interface or to use them to filter data, which we will talk about in an upcoming video. In our next video, we're going to continue to look at our searches, and more specifically, we're going to look into time ranges and how we can look at relative, absolute, and manually chosen time ranges.